The last talk in this session is by Merihan Alhafnawi, and I hear she's going to be doing a demo. Merihan, are you setting up some robots and things? Okay, she's doing that at the moment, so I'll introduce her while she's doing this. It's really nice to sort of end the day with an early career researcher giving a talk about some of their work. So Merihan is currently a PhD student in robotics and autonomous systems, and she actually works at the Bristol Robotics Lab just up the M32. Prior to that, she did a master's using basically swarms of robots to kind of as a canvas for drawing things on. And from what I understand, she's going to be talking today about some of the work she's been doing in her PhD about how humans and swarms of robots can actually interact. So I think, are we nearly ready with the... Yes. We're nearly there.
Hopefully that's fine, yep.
Good. Okay, so do you want me to hand over to you then?
Yes, we'll just connect the laptop.
Brilliant. So I'll let Merihan tell you more about her research.
Cool. All right, hi everyone. I'm Merihan, and I'm a PhD student at the University of Bristol. So I study robotic systems, and specifically looking into swarm robotics, which is using many agents in order to do a task. So instead of just one robot. And I specifically look into human interaction. So how can a human interact with robots? These robots collect data. So how can the data be expressed in a way where, it's intuitive for the human to understand? All right, and if we look into swarms in nature, that's actually what inspired robotic swarms. So if you look into flocks of birds or fish, schools of fish, or swarms of bees or ants, they use many agents in order to do tasks. For example, like hives in bees. And robots do the same thing. So they interact together in order to do a task. Also, if one of the agents falls, the rest of the agents can continue working, same as, like, for example, in birds and bees. So yeah, it's really inspired by nature. And there are many applications where swarm robotics can be useful. So for example, swarm robotics has been researched to build architecture, like to build structures. Also, we've also seen things in Amazon and Ocado where robots are now being used to manage warehouses. NASA is looking into sending a swarm of robots to actually do planetary exploration. So instead of one, you get better coverage. There is a company here in the UK called Wind Racers that are looking into sending a swarm of drones to do firefighting. So obviously, again, you have better coverage and more drones can help each other put down the fire. Eco-friendly swarms are being researched also to clean up oceans. So there are a lot of applications. These are just some of the applications, and there are many more. Okay, but in order for robots to actually do these tasks in these applications, they need to collect data. So if we look into how single robots first collect data, there are many ways, and these four things are just, some methods. So first, we have sensors. We have, for example, proximity sensors where robots could detect obstacles and try to avoid them. Temperature sensors, so these could be used on the drones in order to locate a fire. Robots have cameras. Obviously, camera is a sensor, but it's very useful in that the robots could take videos and analyze frames or take photos and try to, for example, detect humans or detect objects of interest. You could also put data into the robot yourself, so human input, humans put entering data onto the robots, and communication. So sometimes you would put beacons in rooms, for example, where the robots could communicate with these beacons, maybe to update their tasks or update their states, or also localize themselves. So, I know I'm in this room because I'm communicating with this beacon. But if we look into swarm robots, they have all of the mentioned before, plus local interactions. So that means that if I'm in an area and there is a robot somewhere else, I could utilize that robot sensors to know what's happening in that area. Why? Because I talk to my neighbors, and my neighbors talk to my neighbors, and so, together we could work on tasks and help each other out. So this is very important, and it gives swarms three main advantages. So swarms are robust because if one agent falls, the rest of the agents can continue working, much like birds and fish. They're scalable, so you could add or remove robots, depending on your tasks, and we'll talk more about scalability later. And they're flexible, so as I said, like one robot could be doing something else in another area, and then it could call on its neighbors to come and help it out. So they're flexible in that way. So this is all good. So we have a couple of agents doing their own thing, interacting together, sensing the environment. But as Neil said previously, we would need a human to be in the loop at some point. So imagine there's a swarm deployed somewhere, and then a change of the mission happens, or like you need to communicate changes to the mission. So what you would do is that you would want you as a human to interact with these robots without breaking the decentralization of the swarm. So without communicating with each and every single robot, because you might have thousands of robots, so it would be unrealistic to do that. So how can we do that without breaking the decentralization of the robots and at the same time influencing their behavior? So this is actually what I look into in my research. Okay, so the first project that I worked on was called Robotic Canvas, and Robotic Canvas was the subject of my dissertation. And we were trying to figure out how can we discover the underlying methods of human-swarm interaction in a fun context that's also simple. So we use kilobots, which are robots developed in Harvard. They're very small, like 3.3 centimeter in diameter. They have an ambient light sensor, which senses the intensity of light, and they have an LED, and they have vibrating motors, which is a very interesting method of movement, because they vibrate to get into locations. And Robotic Canvas basically is a swarm of robots, 222 robots, that interact with a human to create paintings. So first you have a projector that projects images on top of the swarm, and the robots are able to detect the color of light and reflect it back to you via the sensors, via the LED. So they're able to show the painting actually through their LEDs. And then you can interact with the painting either through hand gestures, we'll see how, or through a dedicated robots that we call the toolbar. So first I'll give you a quick performance that we did with the robots just so you understand, and then we can go through the interaction modes that made this possible. So first, sun sets on an ocean, night arrives, stars begin to show in the night sky. More stars begin to show. Clouds have formed as well. And then finally, the sun rises again. So this is work I did with my supervisors, Sabine Howard and Polo Dout, and it's published in eLife. Okay, so how did we do that? We used 6 different interaction modes. So first is light painting mode. So we talked about how we want humans to interact with robots but do not break the decentralization of them. So one method to do that is to change the environment or manipulate the environment around the robots. So here I'm projecting an image on top of the robot. You can see it on the corner here, and then the robot is just detecting the color of light and reflecting it back to me. So I'm changing the light around them in order for them to respond to me. The other way also uses environmental interactions. So here, when they sense a drop of ambient light, they turn off their LED, and that's why I called it a razor, because it just turns off the LED. So this method is called palette coloring, and it uses, remember we talked about the toolbar, it uses dedicated robots that hold color data, so color information, and when the robots are within communication range with one of these robots, they know that they need to change the color of their LED. And this exploits local interaction. So I'm pretending I'm part of the swarm, and I'm giving data to the swarm. Copy and paste also uses actually both environmental and local interactions. So here, when the robots detect a drop of ambient light for 5 seconds, they know that, oh, we're in copy mode now. So they give me feedback by blinking, and then they talk to their neighbors and tell them, if you also see a drop of ambient light, that means that the hand has moved over to you, so show this specific color. And then when they detect the drop for 5 more seconds, they know that, oh, we're now in paste mode. They blink to tell me, yes, we know we're in paste mode now, and the pixels are pasted. So one of the things we learned here is that feedback is very important, because without feedback, I wouldn't have known if I'm in the copy or paste mode or whatever. And here I use 2 hands just to show that multi-human, multi-robot interaction is possible with this. Undo all mode. So undo all uses this robot, which is called the undo robot, and what it does is that it propagates a message that goes throughout the whole swarm, telling them to go back to light mating mode. And the feedback, you can see, here is the red wave, and that means that every robot is telling me, oh, I understand, we're going back to undo all mode. And this causes the robots to speak to their neighbors, telling them, oh, please propagate this message onwards. So the message keeps propagating until all the robots heard the message. Save all mode is the same thing, so I'm just going to go over it quickly. It propagates a message that tells the robots either to save or retrieve their current LED color. So that means that you could save or retrieve 5 different paintings. Okay, so what we learned here is the underlying mechanism of interactions. So things like manipulating the environment around the robots and pretending to be part of the swarm in order to send messages also through the swarm. So send data through the environment, through local interactions, exploit that. And we also learned that feedback is very important because otherwise we wouldn't know what's happening. So that's great. So we can fill we discovered that you have to fill the whole shape with robots in order to present an image, but can we do better? So the second bulk of work we did with the kilobots was called saliency detection and representation, where we told each robot to share color data with their neighbors. So each robot now gets 20 or 30 different color opinions of what the robots are seeing, and then it's able to represent edges. And how it does that is if the robots, like here, for example, here, if they all agree on the color, then they just keep moving randomly. But if the robots, like those in the middle, receive conflicting opinions, so conflicting data from their neighbors, then they know that they're standing on an edge because some neighbors are saying, oh, I see yellow, some neighbors are saying, oh, I see blue, so they know that they're standing on an edge. So just by sharing data and processing it, we can have edge detection for free, basically. And so we can use a less number of robots to still be able to present shapes. Oh, and we did that with large number in simulations, and we were able to actually project animations and have, like, for example, a blinking eye. And this has to do with scalability because we used exactly the same code with different number of robots, 300, 500, and 1,000 robots, and it still worked. Great, well, that was good. We understood the underlying mechanisms, but we can't really take the robots out of the lab and use them in other applications. So we were thinking we want to use swarms in a new context that hasn't been used before, and this is social settings. So swarms for the people to help them with things like brainstorming, decision-making, collective intelligence. And we thought that with the kilobots, it wasn't like very intuitive, like how to interact with these robots. So can we do better? And we got a fund from Nesta, and we built a swarm of touchscreens, basically. So the whole system is called MOSAIX, and the individual robots are called tiles. And we designed and built them to be very intuitive. Everyone has a touchscreen, probably from their phones or tablets, and we thought like touchscreens are very highly programmable. You can program them to show buttons, you can draw on them, you can show different images. So that's why we built literally a swarm of touchscreen, and we called them MOSAIX. And we already used it out of the lab. So for example, we went to Cabot Circus, and we asked people to tell us their opinion on climate change. So what we did was we showed them a couple of options, and we told them, what is the most important thing for you to do to battle climate change on a personal level? And then we showed these options on the robots, and then when people press the option, it shows on the screen, and it mixes in a sea of other opinions, so that when people come around, like those people here, they can look and see what other people thought of, and maybe that would encourage them to enter their opinion. And that's what really happened. Like we felt that the robots are empowering people to tell us their opinion and have a conversation. And we thought that this is good, but we need to make sure that this is really the case. So we did a user study where we made people hold the robots in their hand as if it's a mobile phone or whatever, and just enter their opinions, versus the robots mixing around, like I said before, like what we did in Cabot Circus. And we wanted to see, what their reactions on that was. So we saw that people thought that the robot interaction was easy in general, like in both situations, and that they were comfortable sharing their opinion using the robot. So we know that the platform is not an issue, and it's easy to use. they felt more anonymous in the moving condition, and we felt that this could be empowering for people who are shy or afraid to speak up, that they can still, tell us their opinion just through the robots. And the number of interactions per participant actually increased in the moving robots versus the stationary robot, and this was something that we were very happy to see. And then finally, the difference between their first and last opinion changed. So it was a scale from 0 to 100, and then they enter their opinion on that. And actually, that meant that by the end of the experiment, their opinions changed. That means they talked to each other and influenced each other, and that's something that we wanted to see as well. During the UK Festival of Robotics, we actually used the robots. It was online last year as a collaborative art tool. So we gave access to people to enter on a website and move the robots around. So they're strangers on the internet. They just have access to robots in the BRL, in the Bristol Robotics Lab. And actually, we saw really impressive things happening. So first of all, like a footballer emerged. So these, again, are just different people that decided together to create a footballer. A palm tree. There was a horse project here, but someone didn't want a horse to happen. And the smiley face. And not only that, people actually chased each other around the arena, and they knocked over the robots, which was an amazing durability test for the robots that thankfully they passed. And yeah. So that was nice to just bring people together, especially during the pandemic where everyone had to stay at home. We took also a swarm of 9 robots to school kids. So we asked the kids to, basically the robots were moving randomly in this arena, and the kids had to figure out a way to stop them, which was just to touch the screen, and put the robots together into this to show the Mars Perseverance rover. And this was they found that the activity was interesting, so we thought that, okay, now we can talk to them about STEM careers and robotics and space and swarm robotics. So that was nice. And then finally, I'll just go through quickly the future applications of these robots, of MOSAIX. First is brainstorming. So imagine when you're in a team and you're trying to brainstorm for ideas. You write your ideas on Post-it notes. You can have 50, 60 Post-it notes. And then, some of these ideas can go missed because you have so many Post-it notes to go through. So the idea here is to actually have the robots aggregate based on different themes. So you would enter your idea on the Post-it notes or on the robotic Post-it notes, and they would aggregate just based on different themes. That makes it much easier for teams to go through the ideas faster and maybe focus on the themes that they're interested in. And we're going to try this next week in the Bristol Data Week, on Monday, June 13th. So please come along. You could also use the robots as a creative art medium. So it's literally a sculpting material that you can move around, draw on, show images, etc. So sky's the limit. And you could use it as spatial interaction. So we thought that if you could have the robot act as your personal avatar. So for example, if you think of networking events, the robots you could enter data about yourself, and then the robot could take you to meet people of similar interest in networking events, or take you to places of interest in exhibits and museums, for example. And also if they interact together, the robots, which they do, they could help the crowds. So we know that this exhibit is crowded now, so I'm going to take my human to that area first in order to, divide and conquer, I think, the humans. All right, so I'm going to give a really quick demo. And if you're interested more, you can come next. Yes, you can come next week. But this is going to be super quick because we don't have time. So this smiley face, I know, can bring nightmares. But we were thinking of the idea of Swarmoji. And Swarmoji is, can we bring swarm robots together to give you an update on a task, for example, but showing emojis? So this is just an idea that I'm putting out there, is that robots can come together and give you thumbs up, smiley faces, etc. And here, I'm going to show really quickly what you would see if you come next week. So we're using this as a smart Post-it note. So here, okay, we can see this. We programmed it to show a keyboard, so we programmed a keyboard on the robot. And then if you enter your idea, so I'm just going to write idea really quickly here. Idea. And then you press enter. All right, so your idea will be shown to other people, and then hopefully the robots then would, aggregate to show different themes. The other thing is that I didn't tell you, but the robots have cameras. So I'm just going to show a really quick demo about that. So right now, I have a QR code here, and this says searching for code. Oh, this is harder than I thought. So if I bring the code to the camera, hopefully it will say that it found it. Found. So this is just a detection. So it says here found. You can do face detection. You can do different detections. And I'm not going to demo that because there's no time. It can also do obstacle detection. So it wouldn't like run into you. It will try to avoid obstacles. But yeah, thank you so much.
Thank you, Merihan. I think she's braver than I would be in doing a live demo at the end of her talk, so that was great. I think we've got time for one quick question, if anyone's got a burning question on the tip of their tongue.
Hi, thank you. I was just wondering if there's currently much research being done on human swarm interaction with smaller devices, or is it currently focused on sort of handheld robots like you've been working on?
Smaller as in like on the nanoscale or micro scale, something like that?
Either.
There is a lot of research happening on microscale, like micro swarms and nano swarms in general. Obviously, you still have to have a human in the loop if you want to deploy systems. A lot of it has to do with cancer research. So, can we deploy nano swarms to help, with cancer or delivery of drugs and things like that? Anything you would need human interaction, but it would be very different than just having robots that have like sensors that you can deal with.
Great, thank you.
Yeah,
Brilliant. I had one very quick question.
Yeah.
So when you end up with lots of agents, you often have conflicts. Humans are a good example of that. And I'm just wondering, you mentioned about kind of themes or ideas emerging. Does the swarm have conflicts where there are similar themes where like an idea could go to either and it has to make a decision or come to some resolution in terms of those things?
Yeah, definitely. So for brainstorming, I'm using natural language processing. And so, it gives scores to all the ideas of its neighbors. And sometimes the score, usually I'd say, go to the score that, is highest. But then if it has a very similar score, then it's just a 50-50 chance. Like, just go to whatever's closest to you. Yeah.
Cool. Thanks very much.
Thank you so much.
So let's thank all of the speakers from this session again.